Number 31. So here's possibilities for P over possibilities for Q. Alright, so for P we've got, looking at that -9 there, plus or minus 1, plus or minus 3, plus or minus 9 over possibilities for the factoring of 2 there, plus or minus 1, plus or minus 2. So the possibilities for P over Q. Alright, so we've got 1 over 1 plus or minus 1, 3 over 1 plus or minus 3, 9 over 1 plus or minus 9, 1 over 2, that's plus or minus a half, 3 over 2, that's plus or minus 3 halves, 9 over 2, plus or minus 9 halves. And that takes care of all the possibilities. Alright, so this one, if you go down this list from left to right, it's going to take you quite a while. So let me save you some time if that's the way you're doing it. 3 halves is a good one. So we've got 2, -5, 9, -9. So let's see, we got 3 here, -3, that's 6, and +9. So that's the one. Okay, so therefore what we have is this polynomial is equal to, in factored form, x minus 3 halves, and then you've got 2x squared minus 2x plus 6. Again, I can simplify this one by factoring a common factor of 2 out. Like that. Then you can multiply the 2 times the first factor. So you get a 2x minus 3 and x squared minus x plus 3. Alright. Now, this one we can't factor over the integers. Alright, so you could use a quadratic formula or complete the square, set that equal to 0 and solve for x. But let's simplify it a little bit. Let's use the discriminant for this. What's the discriminant? If you have the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, there's your quadratic formula. You'll note that everything underneath this square root can either be less than 0. If it is, you're taking the square root of a negative number, in which case you're going to have a non-real 0. Alright? Or this could equal 0, in which case you'd be taking square root of 0 is 0. And so the only answer would be -b over 2a, because you'd have -b plus or minus 0, which is just -b over 2a. Alright, so you'd only have one answer for that one, -b over 2a, if this equals 0. If this is greater than 0, then you would have the square root of something positive, which is a real number. Alright, and it could be irrational or rational. Alright, so then you'd have -b plus or minus something positive here over 2a. Okay, so you would have two real zeros. So you can tell the kind of answers you're going to get by this little thing right here under the square root. That is called the discriminant, and you may already know about this. Oops, discriminant. If I could spell this correctly, that would be good. Discriminant. Alright, there you go. Discriminant. You can discriminate between the different kinds of answers or roots. Alright, that's why they call it that. So instead of going through all this rigmarole here, right, just use a discriminant on this one to see whether it's worth going on or not. Alright, what I'm looking for is real number solutions. That's the directions, by the way, and the problem they gave us. It said find all real zeros. Alright, so if this is not real, the zeros for this, then there's no need to go on. Alright, so let's try b squared minus 4ac for this. A is 1, b is negative 1, c is 3. Alright, so you've got b squared, that's negative 1 squared, minus 4a, that's 1, c, that's 3. Alright, so this is going to be 1 minus 12 is less than 0. Alright, so again, that means that you're taking the square root of a negative number. This b squared minus 4ac under the square root is negative. It's less than 0. So you're ending up with non-real zeros or non-real solutions. There's going to be 2 of them. Alright, so there's no need to go any further. All we need to do then is set that equal to 0 and solve for x. This is going to give us the only real root it has. And so the only real 0 is 3/2. So you may have seen discriminant before and forgotten about it. Alright, it's kind of a, I don't know, it kind of gets lost in the shuffle because it seems so small and minor. But in something like this, it saves you a little time. So hey, it's worth remembering. Alright, so again, when you get to this point, use a discriminant. If you can't factor this thing, use a discriminant and check to see if you have real or non-real roots for this quadratic. Okay, so that's the only real 0, 3/2. By the way, if you're curious, the other 2 roots are 1/2 plus or minus square root of 11 over 2i. So the leading coefficient is 1, so all we have to do is get the factors of 12, and that'll give us our possibilities for p over q, the rational root possibilities. Alright, so we've got plus minus 1, plus minus 2, plus minus 3, plus minus 4, and plus minus 6, and plus minus 12. Alright, so it turns out that minus 1 works. If you write your coefficients down, we can do this synthetic division. We'll get a 0 remainder, and then we can start factoring this polynomial. So here we go. That. So that means, therefore, we can factor the polynomial x to the 4th minus 2x cubed minus 7x squared plus 8x plus 12 as 1x to the third, or x cubed, or rather we can do this part first. X minus a negative 1 is x plus 1, and then we can write x cubed minus 3x squared minus 4x plus 12. Okay. So what you would do is, if in case there's a multiple root of negative 1, you would try it again on this polynomial. Now you didn't have to write this line that I just wrote here. Just put the negative 1 over here and do a synthetic division again and try it. Alright. Turns out it doesn't work though. The reason I wrote this line is just to clarify what's going on. Okay. So try one of these other factors. 2 works. And you use it on this part right here. That's the quotient. 1, negative 3, negative 4, and 12. Alright. So therefore, this polynomial equals, what we've done is, with this result, we've factored this part right here. This remains x plus 1. Then we've got x minus 2 from this division here, x minus 2. And then what we have is x squared minus x minus 6. Alright. Now this can be factored. So we've got x plus 1, x minus 2, and x plus 2, x minus 3. Alright. So from these you can easily get the zeros. The zeros are negative 1, positive 2, negative 2, and positive 3. So, negative 1, 2, and negative 2, and 3 are your zeros. $35. Alright, so possibilities for P over possibilities for Q so we've got the factors of 6 on top here. That's plus or minus 1, plus minus 2, plus minus 3, and plus or minus 6. And underneath we've got the factors of 4, plus minus 1, plus minus 2, and plus minus 4. Okay, so the possibilities for our rational roots, possible rational roots, P over Q. So we've got, starting with this, and put it over each of these, we've got plus or minus 1, plus or minus 1/2, plus or minus 1/4. And starting with a 2, we've got plus or minus 2. Plus or minus 2 over 2, that's still plus or minus 1, which we already have. And then 2 fourths, plus or minus 2 over 4 is 1/2, so we already have that. And then going to 3, this is plus or minus 3 over 1 is plus or minus 3. 3 over 2, plus or minus 3 over 2. And then plus or minus 3 over 4. And then 6, plus or minus 6 over 1 is plus or minus 6. 6 over 2 is 3, so we already have that. 6 over 4 is 3 over 2, which we already have. So it stops right there. Okay. So 2 works on this one. Alright, so that means that this polynomial, 4x to the 4th plus 4x cubed minus 25x squared minus x plus 6 can be factored as x minus 2 and then 4x cubed plus 12x squared minus x minus 3. Alright, and what you need to do is try 2 again on this part here, see if you get a 0 remainder. But it's in case you have a 2 multiplicity more than 1. But that's not going to work. So you keep going through your list and finally you get to -3. And we're doing it on this result here, 4, 12, -1, -3. Alright, so that means that this polynomial, after doing this, I'll just bring an arrow down here, is equal to x minus 2, and then we just factored this one. That's x minus a -3 or x plus 3. And this stands for 4x squared minus 1. 4x squared plus 0x minus 1. And this can be easily solved. Set it equal to 0 and then solve it. 4x squared minus 1 equals 0. So 4x squared equals 1. X squared equals 1/4. Let me continue over here. X squared equals 1/4, and then take the square root of both sides, so you get x equals plus or minus 1/2. Remember, there's a positive and negative square root. So the zeros are 2, -3, and plus or minus 1/2. Alright, 2, -3, 1/2, and -1/2 are the zeros. Okay, 37. So, since the leading coefficient is 1, all we have to get are the factors of 5 for our possible rational roots. So the possibilities for P over Q are going to be the factors of 5, plus or minus 1, plus or minus 5. Alright. So it turns out that negative 1 is what we're looking for. There we go. And so this polynomial is equal to x plus 1, or x minus a negative 1, x plus 1. And then we've got x cubed plus x squared minus 5x minus 5. Okay, and try minus 1 again. I'll just write it right here to save a little time. So negative 5 plus 5 is 0. So there we go. So that works. We've got a negative 1 multiplicity 2. Alright? So that means this polynomial can be written as x plus 1 times x plus 1 and then we've got x squared minus 5. Or, simplifying it a little bit, x plus 1 quantity squared times x squared minus 5. Now you can set this factor here equal to 0 and solve for x. Taking the square root of both sides, you get x equals plus or minus square root of 5. Okay. So the roots are negative 1 multiplicity 2, and the square root of 5 and negative square root of 5. Number 39. Alright, the possibilities for P over possibilities for Q. So factors of 6 plus minus 1 plus minus 2 plus minus 3 plus minus 6. Factors of 8, that would be plus minus 1 plus minus 2 plus minus 4 plus or minus 8. Alright. So the possibilities for the rational roots P over Q . So we've got, I can go this way, just go down each of these and put them over 1, and then go each of these again, put them over 2, and so on. So plus minus 1 over 1, that's plus minus 1. Plus minus 2 over 1, or plus minus 2. Plus minus 3 over 1. Plus minus 3 over plus minus 1 actually, but it all evens out to plus minus 3. Plus minus 3 over 1 is, or rather plus minus 6 over 1, that's plus minus 6. Now we can go to this one. Plus minus 1 over plus minus 2, that's plus minus a half. Plus minus 2 over plus minus 2 is plus minus 1, we already have that. Plus minus 3 over plus minus 2, that's plus minus 3 halves. Plus minus 3 over plus minus 8 is, or rather, plus minus 3 over plus minus 4 rather, that's plus minus 3/4. And we've got plus or minus 3 over plus or minus 8 is plus minus 3/8. Alright, then going to the 6, plus minus 6 over plus minus 1. We already have that. 6 over 2, that's 3, we already have that. 6 over 4, that's 3 over 2, we already have that. 6 over 8, that's 3/4, we already have that. Okay, so you go down the line and you get to negative a half. And the clue is that just might work for you. Alright, so we've got, let's see, 8, 26, 39, 26, and 6. Oops, let's see, that's 20. That should be a negative 4 there. Negative a half times 8, that's negative 4. So, let's see, 22. And then we've got negative 11. And we've got 28. And negative 14. And 12. And negative 6. Alright. So this polynomial can be written in this form. Let me write it down here. I'm not going to write the whole polynomial out. I'll just write the factored form so far. Factored form x minus negative a half or x plus 1/2. And then we've got 8x cubed plus 26x squared plus 28x Alright, now that's going to work. Okay, so we've got 4x cubed and 22x squared, that's 11x squared. And then 14x and 6. Alright. Now what you can do is take this 2 and multiply it by the first factor. Kind of get it out of the way, so to speak. 2 times x is 2x. 2 times a half is 1. Alright. You could try negative a half again on this part here that remains. It won't work, unfortunately, so you go through the other possibilities that you have not tried yet. Okay, anything that you haven't tried is fair game. And you finally get to a minus 3/4. That'll work. So 411, using it on this here. 4, 11, 14, and 6. Okay. So the polynomial can be written, what we did was just factor this one. So we can write that as 2x plus 1 x minus a negative 3/4, which is x plus 3/4. And then 4x squared plus 8x plus 8. Alright. Now you can simplify this a little, factor a common factor of 4 out of this last factor, and then use that 4 and multiply it by this. Okay. You could multiply it by this, but you can only do one or the other, not both. Alright, so you take the 4, if you multiply it by this, the fraction will clear out of there. Alright, so you're going to get 2x plus 1, and then you got 4x plus 4 times 3/4 is 3. And then you factored the 4 out of there, so that's x squared plus 2x plus 2. Alright, now this cannot be factored over the integers. Alright, so you can try factoring it, but you can tell it's not going to work. You can check the discriminant on that, and you'll find that it's less than 0. It's a negative number. So you're going to get a non-real root for this, and you would use a quadratic formula to find the roots for this part right here. Alright, so we can do that. So to avoid having to erase, let me try to do it up in this little area here. Separate it off. Alright, so x, using the quadratic formula, x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2 all over 2 times 1. So you're going to get negative 2 plus or minus square root of negative 4 after all is said and done in there over 2. And this is equal to negative 2 plus or minus a 2i over 2. And you can factor the 2 out of the top and then cancel it with a 2 down below. Like that. And so you get negative 1 plus or minus I. There you go. Alright, so to get the zeros, you set each of these factors equal to 0. We already know what that answer is going to be, or those answers for this factor. Set this equal to 0, set that equal to 0, solve separately, and the zeros are going to be negative a half, negative 3/4, negative 1 plus I, and negative 1 minus I. Now the directions, we went a little bit further than we needed to. The directions just call for the real zeros, so I could have stopped right here, alright, and just gave the real zeros. But I thought I'd go a little bit further as a preview of coming attractions, alright? Okay.